Alright, it is not recording. Let me go back very quickly. So I forgot to hit record. What I was saying essentially was we're going to discuss very briefly what the future of this project could be, and this is just an outline, doesn't have to be totally fitting. And so we are going to be looking at how we can leverage this this work we did yesterday, the transcription work, for further making sense. So to make further sense, right? So what I have here is I'm inside the Faster Whisper Conda environment, and inside my folder you can see two or three new files, the vid.mp3, transcription.txt, and infer.py. And essentially what this contains is that this infer.py is all it's doing is doing transcription, right? It's running it on GPU because it's using distill large v3 because my GPU went out of memory with the regular large v3, and I can't fit the FP16 version. It'll fit the FP32 version because it's Pascal architecture. The GTX 1070 is Pascal architecture, and it's pretty old, and it won't be able to do proper FP16 computations. It's not for GPU itself can do it, but it's not really fully supported to do FP16 comps. So it'll by fallback result to FP32. Now that's one thing. And this is like loading the Whisper model on GPU and start the transcription. There is a vid.mp3 file. I'll explain what vid.mp3 file is, and then this is the transcription process. There's the timing aspect, and then there is the actual segments, and write the output of these segments to a text file and compute the total number of words, because we want to compute the throughput. So how many words per second are we able to transcribe? And then we also finally output these values. And there is a bug in the audio duration. For whatever reason, I think it's getting evaluated to 0. We'll find out that once I only found out after running the benchmark. And here basically gives you the detected language and final closing thoughts if there is no such file. Now, what is vid.mp3? Well, really this is a file that is generated by ffmpeg, and this is the command that takes in the file, the .mkv file, and outputs a .mp3 file. So it's just conversion with ffmpeg. I had to just install ffmpeg with sudo apt-get install ffmpeg, and so now we have the .mp3 file, and I already ran my inference script, and inference script outputs a transcription.txt, and here is the transcription.txt. Seems like it did a decent job. It's doing pretty good. I think it's, for example, kubloss, right? Kubloss. It's not too bad for a new word. And, it seems like pretty decent. So you have all these transcripted text, which looks fine. And in the end, like I said, there is an error over here. There's a bug because it's probably evaluated to 0, and it's incorrect. The interesting part is the whole 3 hour 20 minutes transcription was completed in 43 seconds or 44 seconds. And if you do the counting of the number of words per second, that's like 414 words per second that it is able to transcribe on a very, very underwhelming GPU such as GTX 1070. Now imagine if you're able to run this on a H100 or A100, you would be actually very surprised how fast it can run. and I'm actually very excited because a 3-hour 20-minute audio was able to be transcribed in 43 minutes. Isn't that cool? Now you could also, by just calculation, find out how many seconds of audio were transcribed per second. So you could do it this way. I had done it, so you have that thing popped up here. There were 3 hours, so that's 3 times 60 times 60, plus there was 20 minutes, so 20 times 60, plus 15 seconds. So that's 3 hours, 20 minutes, 15 seconds for the clip. And then the whole clip transcription was done in 44 seconds, right? To be precise, 43.7 seconds. So that means it was able to process 274 seconds of audio per second on a 1070. So I think it's pretty cool. So now what can we do with this, right? We have this transcription.txt file, and we just need this txt file to be consumed by something else, right? What can we do? Well, there are several things we could do, and I think the extent of this video could be that we could probably just outline what we're going to do and just take a look at a few libraries, because it's getting slightly late and it's about to be 10 o'clock here. So 10 p.m. and tomorrow is a Monday. So we start by identifying our basic input structure. You have a video file. You would use FFmpeg to transpose it, convert it into an audio. And once you have this audio, you could really take this text, right? There's the transcribed audio text. Now, there's one more thing we could do, is you have text and you also want to ID this. Suppose you have a podcast, right? It's great that you can transcribe, but also you want to know who said what. So that way you can attribute or ask follow-up questions about the particular person of interest, right? Maybe the host has a certain opinion, the interviewee has a different opinion, so we want to know what their positions are. So you really want to have an ID, right? The transcription would not be useful as much if you are not able to identify the speaker. So we want to be able to do that, and combining these two, you could really have it, so we combine these two and put it into a LLM, right? So we can put it into an LLM, and there we have it. That is our LLM. So we can put it to an LLM, and we can. So what's the purpose of putting it to an LLM? Well, we could do several things. Depending on the use case, right? So that's the use case. I'll just draw an outline here to stop and think about this. So you can put it into an LLM, and when you put this into an LLM, you could do several things. One, you could do Q&A with the material, right? So you could do something like question answering, aka RAG. You could do just an overview of the podcast, right? Or you could do something like, let me add this one here. Maybe take a podcast or a video of importance, and I'm sure this is already implemented. I'm very confident somebody already implemented this, but we're just doing this for fun and learning. So we're gonna have some fun here. So you could do Q&A, you could do summarization, summarize. Yeah, you could do summarization. Okay, so you could do, what else could you do? You could do, maybe you could do like a data set production, right? Which is also, you could use LLMs to produce data sets, right? So produce data sets, and LLM is probably going to chop out all the unnecessary stuff in the material, and it'll do some clean processing. I mean, you really don't need LLMs for doing pre-processing, but also you could do some sort of intelligent pre-processing. So you could leverage LLM for that. And what is the point of this data set, right? What is the point to produce something like this? Well, if you think about it, I have it in a different section. I'll call this northbound and southbound. I'll call this just the southbound, or just say south. So what is the point of the data set that you produce with the text? Imagine this. Suppose you run this whole pipeline for the whole data set production pipeline for many podcasts, right? So say you are a certain podcaster's, you like a certain podcaster's opinions, so maybe you want to, or a lot of the business interviews happen, right? Maybe you like Elon's way of business, right? Maybe you like Zuck's way of approaches or advice. Maybe you like, I don't know, you like a certain influencer, right? Okay, Lex Friedman. You like politics. If you want to have some fun with politics, you want the model to be interesting and funny, or to be making sense. So you like probably whoever you like, right? In politics, you like because it's 2024, we have two major contenders. We can call Joe Biden and Donald J. Trump, right? So you can bring those elements in, and you like who else? You like a bunch of people, right? So and you know that a lot of the content is available here. So you have a lot of this material from these interesting people available here on the internet through podcasts, videos, interviews, and so many other portals of conversations. So you bring it all in, and now you produce a certain data set, and finally you feed that data set to, maybe you want to create a unique maybe you want to create a unique AI based influencer, right? So you don't really need them, the influencer, to sound like them, but if you want, you can leverage their data set and have the AI be kind of thinking or sounding like these people, right? And maybe you like, instead of these, I could say a lot of these popular viral social media celebrities, right? Maybe you like Andy Elliott, right? He's the car sales guy who's kind of skyrocketed his way through viral videos and such. You like, some other salespeople, right? Grant Cardone, right? You like Gary Vee. these patients hustle, etc. So whoever you like, you could sort of produce appropriate or their way of sounding data sets, and you can produce an AI influencer. The way you would do that in the South is you take this data set that you produce and you fine-tune the model, fine-tune an LLM to sound like them. Maybe you fine-tune a llama or whatever, right? So you would fine-tune a llama 3 or whatever the state of the art that you like and that you can fine-tune on. You take that and now you have a fine-tuned model, and when somebody asks a question, the llama model responds to you in a way that you like, and then this is your AI influencer. Now the key is you get everything in text. AI based influencer, LLM response, right? You have it in text. You could you could get the response out, right? And then you could turn this into audio, and you could also give the same voice and speech behaviors to produce some text and video as well. So you have like a character that looks like this, your AI character, right? So you first have to connect it to a text to speech, and you would take the emotions and the facials. I'll say TTS emotions plus face plus lip sync or something like that, right? You can make maybe like you can have fun. You can have some fun with, maybe you can take Marcus Aurelius pictures and have a unique Marcus Aurelius material come through with this channel. There are so many what is the word? I don't recall. There are so many what are they called? So it's called, I think, Stoic. Yes, Stoic. Yeah. So you can have a flavor of Andy Elliott plus the Stoics come together in life, and now you have a special AI character, right? This is what you could do to build a AI character. And the way you would take it from text to speech, and you get the AI character by, I think you could do what's called Halo, I think. Halo, HALO, I think. You can look it up, we can look it up. And finally you have a character that has a unique perspective, not perspective really, but a different way to regurgitate the material, and is interesting, and possibly if you add your folks here, maybe you add a comedian, a stand-up comedian or whoever, it is also kind of funny while teaching some life lessons, or things like that. So the limits to producing something like this is very, very exhaustive. Like there's so many things we could do, and I don't think we'll worry about the southbound yet. At least in this series, we'll probably be able to do the northbound, where we take the audio video, we turn this audio video into an audio, and then you text and find the IDs, and then we can do LLM based outcomes, right? So you take the LLMs and you produce the outcomes, and probably you can save everything to a PDF or something like that when you do RAG. And finally you have a pretty cool material that itself is pretty cool, right? So the northbound itself gives you nice outcomes, right? So there is some value for sure in doing something like this. But if you add more, right? There is certainly value in producing like a PPT or a PDF because of RAG. You already helped people to save a lot of time, right? By being able to answer specific questions of the 4-hour or 5-hour, 6-hour conversations. So you could do it that way. You could also take it southbound, and in the southbound you can have these interesting, very cool AI characters. An AI character, AI influencer can be, this is one of many ways to build something like this. The value here is what? The value here is it's another video. Value here is what do you get as an output? You have another video. Let me just take out the other, but you have a video, right? You have a video, and you could, instead of connecting the hollow, you could take this another route as well. So you could, if you like, connect it to, let me add this here. Let me check. Yeah, you could take this TTS, the output of TTS. You could condition it to sound like a certain person, right? Maybe a stoic voice, maybe a voice conditioning, right? Right? Maybe you want this to sound like you. You can do, I think it's called neural voice transfer. I think so. We can look it up. But basically, you can condition the output itself, and there you have a way to talk and sound like somebody with some unique material, right? So that's another output. The value there is what? The value that we get from this is you get an audio, and still you can probably have the audio conversate as well. So conversational audio, now the question is, how are we going to reduce the latency, right? Because this is all I'm just like just thinking about the architecture. I've never implemented this, so you take it with a grain of salt, but this is one way to think about it. So what is the actual latency? The latency is from here. You have LLM response. I mean, at least for southbound, what is the latency? I'm not talking about northbound now. LLM fine-tuning. After the fine-tuning, you have a response. The LLM inference latency, right? That this is the response time, and then the other latency is coming from the text-to-speech. Right, you have to do voice conditioning. Now the key is, if you want it to be more updated, you can connect the LLM response to the internet. That'll add more latency as well, right? So you connect this to the internet, right? However you choose to connect, right? So you can use LangChain or other things that we could possibly explore, and that'll give you more like updated response. I think I have to look up. There's a open source version of Perplexity. It's called Perplexica. You all can look it up. It seems interesting. So we can look at how they are connecting to the internet, or we could also hook to agentic workflow, right? So that's another way, because it can go reach out and produce a document. So you take that output, you connect to the internet. However we choose to connect to the internet is something. Now, like I said, I was going, like I was mentioning, the way we would think about this is, where can we fix the latency, right? How can we improve the latency? And that's something that we could explore as well. So wherever you want to hook, right, you can not connect to the internet. That'll reduce the latency. You can of course quantize and do all the fun stuff, compile, and also maybe write some CUDA code, and do all that fun stuff. So there we have it. So this is something to think about, or if you want to look and implement, I'd love to see some implementations. Although I'm fairly confident people have already implemented some of this, and some of them are probably paid products. So that is the something that we could think about. But for top, we may be able to produce at minimum this section, right? We may be able to produce in the upcoming videos, in the streams, right? We may be able to produce something like that. And this is not like all set in stone. This is something that we could explore and have fun learning. This is not really a tutorial, but a exploration work that we could do and have fun. That's the intent, really, to learn and have fun and enjoy and build some cool stuff. So that is, I think, what we may try pursuing in the upcoming videos. And I say that we probably have run quite a bit over. Yeah, it's not too bad. It's 10:18. Yeah, so I'll conclude the video here, and we'll take a look at what to do next in the upcoming videos. Thank you. Let me stop the streaming. Where is the streaming? Yay, stop the stream.